Hello and namaste, dear friends. We often wonder why some lenses have minus powers while the others have plus powers. These signs, positive or negative, are mainly given to distinguish between the types of lenses. Converging or convex lenses have positive focal lengths and positive powers, while the diverging or concave lenses have negative powers and negative focal lengths. Dear friends, now we'll make an attempt to understand why and how these positive and negative signs are assigned. One of the sign conventions we follow is the coordinate geometry sign convention. As per this sign convention, firstly, the incident light is allowed to fall on the surface of the lens only from the left side. Secondly, all the distances measured along the principal axis are measured from the optical center of the lens. Thirdly, the distances measured along the principal axis in the direction of the incident light are taken with positive sign, while that measured against the incident light are taken with negative sign. And lastly, the size or height of the object or image measured perpendicularly upwards from the principal axis are taken with positive sign, and those measured perpendicularly downwards from the principal axis are taken with negative sign. Which means, in a simple language, in a Cartesian coordinate system, if we consider y-axis as the lens, origin O as the optical center of the lens, and x-axis as the principal axis of the lens, then the distances measured in the direction of the positive x-axis are taken with positive sign, while that measured in the direction of negative x-axis are taken with negative sign. Again, the height and size of the object or image measured perpendicularly upwards from the principal axis, that is along the positive y-axis, are taken positive, and that measured perpendicularly downwards from the principal axis, that is along the negative y-axis, are taken with negative sign. The focal length of convex lens is positive. This is because its second focus or principal focus lies towards the right side of the lens, and as per the sign convention, the starting point for measurement along the principal axis has to be its optical center O. So, while measuring its focal length, that is the distance of its principal focus from the optical center, we move in the direction of the incident light, that is along the positive x-axis. Therefore, its focal length is taken positive. Concave lenses have their principal focus or second focus towards the left side. To measure its focal length, that is the distance of f from the optical center O, we move against the incident light or along the negative x-axis. Hence, concave lenses have negative focal length and also negative power, as the power of the lens is the reciprocal of its focal length. In this ray diagram, A dash B dash is the image of the object AB formed by the lens. As per the sign convention, the starting point for measuring the distances along the principal axis has to be the optical center O. The object distance U in this case is OB and not BO. Therefore, object distance U is minus 20 cm. Minus because the object distance OB is measured along negative x-axis, that is against the incident light. The focal length of the lens is plus 10 cm because it is measured along the positive x-axis or in the direction of the incident light. And for similar reasons, the image distance B is plus 20 cm. The height of the object AB is measured perpendicularly upwards from the principal axis, that is along the positive y-axis. Therefore, the height of the object AB is plus 3, not minus 3. Similarly, the height of the image A dash B dash is taken as minus 3 because it is measured perpendicularly downwards from the principal axis, that is along the negative y-axis. In this ray diagram, all the distances, object distance U, image distance B, and focal length F have been given negative sign because as per the sign convention, all these distances are measured against the incident light or in the negative x-axis. 1 by V minus 1 by U is equals to 1 by F is the lens formula or lens equation that relates the object distance U, image distance V, and the focal length F of the lens. This formula or equation helps us in calculating the value of U, V or F if any of the two quantities are known to us. When the image of an object is formed by the lens, if we calculate the ratio of the size of image to the size of the object, then this quantity will be called as linear magnification. This linear magnification helps us in comparing the size of the image with the size of the object. Linear magnification is also obtained by the ratio of image distance to the object distance. It is a pure ratio having no units. The mathematical value of linear magnification will give us the idea about the characteristics of the image formed. If m, that is linear magnification, has negative sign in front of its numerical value, then the image formed is real and inverted. Otherwise, the image formed is virtual or erect. If the numerical value of m, small m, is greater than 1, then the image is magnified. If m is less than 1, the image is diminished. If m equals to 1, then the size of the image and the size of the object are equal to each other. If the linear magnification m is considered to be -2, then it means that the image formed is real and inverted. Real and inverted because of the negative sign. And the image is magnified or enlarged because the numerical value 2 is more than 1. Similarly, the value of m equals to 0.5 implies that the image formed is virtual and erect, and the image formed is diminished.